Most AI agent systems make the same mistake twice. You give 5 agents a task, one of them hits a dead end, learns something important, and 10 minutes later, a different agent hits the exact same wall. Because there is no shared memory, each agent is running blind. Memwright fixes that. And it does it without a single LLM call in the retrieval path. Let's talk about what that actually means in practice. Memwright is a self-hosted memory layer built specifically for multi-agent teams, not a vector database, not RAG, not another wrapper around embeddings. It is a deterministic, structured memory store that any agent in your system can read from and write to in real time, without waiting for a language model to interpret anything. Here is the concrete flow. Agent 1 is working on a research subtask. It discovers that a particular API endpoint returns malformed data. It writes that finding to the shared memory store, a simple key value entry, timestamped, tagged with the agent ID and task context. Now agent 3 spins up 5 minutes later to handle a related subtask. Before it makes any API call, it checks memory. It finds the flag. It skips that endpoint entirely. No wasted tokens, no repeated failure. No LLM had to summarize or embed or retrieve anything semantically. The lookup was direct, fast, and deterministic. The setup is self-hosted, which means your data stays on your infrastructure. You spin up the memory server, point your agents at it through a lightweight client, and that's the integration. The agents write structured facts, errors encountered, decisions made, resources verified, and any other agent can query those facts by key, by tag, or by agent ID. What surprised me was how fast this actually runs. Because there is no model in the retrieval path, reads are essentially instant. We're talking sub-millisecond lookups compared to the half-second plus you'd typically wait for a semantic similarity search through an embedding model. For agentic loops that might call memory dozens of times per minute, that latency difference compounds very quickly. Now here's what Memwright does not do, and this is important. It does not understand meaning. If Agent 1 writes a note about a broken authentication flow, and Agent 2 searches for anything related to login errors, Memwright will not connect those two things unless the keys or tags explicitly match. There is no fuzzy retrieval. There is no semantic layer. You're getting pure deterministic lookup, which is a strength in high-frequency agentic systems, but it is a real limitation when your agents are working with ambiguous or loosely structured knowledge. It also does not handle memory decay or prioritization out of the box. If your agents run for days and write thousands of entries, there is currently no built-in mechanism to surface the most relevant recent facts automatically. You have to manage that logic in your agent code. And it is not a replacement for long-term episodic memory or anything that needs reasoning over past experiences. If you want an agent to learn behavioral patterns over time, Memwright is not that tool. It is a coordination layer, not a cognition layer. So where does this actually go from here? The most plausible near-term use case is encoding agent pipelines, the kind where you have multiple specialized agents handling linting, testing, documentation, and deployment in parallel. Right now, those pipelines either have no shared state, or they bolt on a vector store that adds latency and complexity. Memwright could sit in the middle as a lightweight coordination bus. Agent catches a test failure, flags it, the deployment agent checks memory before pushing. Simple, fast, no LLM overhead. There is also a realistic path toward memory namespacing, where different agent teams working on different projects share the same Memwright instance, but operate in isolated memory spaces. That would make it practical for multi-tenant agentic systems, without having to spin up a separate server per project. If the project adds a time-to-live mechanism for individual memory entries, that would also unlock a whole class of use cases around short-term task context, where you want agents to share working state within a single job, but have it automatically cleared when the job ends. So why does this exist at all? Because the current default for agent memory is either nothing or overkill. Most developers building multi-agent systems either skip shared memory entirely and accept the redundancy, or they reach for a full vector database and spend 2 days integrating it for what is fundamentally a coordination problem, not a search problem. Memwright's creator looked at that gap and made a deliberate bet. For a large class of real agentic workflows, deterministic shared memory is not just good enough. It is actually better than probabilistic retrieval, because you need correctness and speed more than you need fuzzy matching. That is an honest engineering trade-off, and it is exactly the kind of thinking that tends to produce tools that actually get used in production. If you are building multi-agent systems, and you have not wired up shared memory yet, Memwright is worth an afternoon. It is self-hosted, it is fast, and it solves a problem that most people are currently solving badly, or not at all. Next episode, we are looking at another open source tool that handles the part Memwright deliberately skips, the semantic side of agent memory. Subscribe so you don't miss the comparison.